we are starting with a review of the properties that we learned yesterday and of the different logarithmic components that we were learning yesterday. And so today, the first thing that we are going to do is with this logarithmic equation here, we would like to condense this into one logarithmic term. So I will give you a few moments while I pause the video to work on this and try and get it into one term. If you are stuck, I would definitely look back at your different properties of logarithms that we covered yesterday, because those will help you a lot. The first thing, if we want to condense this, that we would need to do is I would like to get this so that the logarithm is in front in this first term. If I just want the logarithm in the front, what should I do with the 5? Using our power rule from yesterday, we can just take this and move it back to the exponent. And then in this second term here, we can do the same thing. So we'll take this 1/2 and move it into our exponent. So we are left with log of 4 to the 1/2. If I have log of 4 to the 1/2, how can I simplify that more? What is 4 to the 1/2 power? 2. So we have log of 2 on the right-hand side here, and we have log of x to the 5th on the left. And if I wanted to take this and then make this all into just one logarithm, I have to use one of my properties. And what will I get? What do you think, Andrew? It is log x to the 5th, but if we have two logarithms that are added together, they will then multiply inside of one logarithm. Exactly. Okay. I would like a show of thumbs. I got this. I would like one more problem to work on, or I don't got this. Okay, let's do one more. Let's go with I will give you a few moments to try out this. And we're doing the same thing, just condensing it into one logarithm. I will pause the recording while you work. Okay, we've gotten a little bit of time now. So I would like row 5, person 1. The dice love you. Can you just start simplifying one of these terms?
On the right, 27.
So we have log of 27 to the 1/3 power, which we said is the same thing as the log of 3. Okay, would you like to count somebody? Row 6, person 4 would be Will, since we have a student in front there. Can you help us simplify this first term? Okay, so if we have this 3 and this 4, do we add those, or do we multiply them, or do we just leave them alone? Yeah, let's multiply those. So we have the log of x to the 12th. So if these are our two terms here, let's call on row 6, person 2. We would have 3x to the 12th. Somebody asked, can we rewrite this as 12 times the log of 3x? Thank you. And the answer is yes. Those are equivalent. Okay. From here, we've done a lot of stuff with our product property. I would like to do an example with our quotient property instead. Instead of condensing this all into one logarithm, I would like you to expand this into as many logarithms as you can, and then simplify it. So don't condense, but expand it, and then simplify it. I will pause while you work. Caroline, can you tell me what you did first?
Well, I did 27 on the top. It starts off with log 27. So I I'm just
Yeah.
divided by the rest.
Yeah, so it's divided by the rest. So if it's divided by the rest,
Then
parentheses, log x plus log y. And then if we were to distribute the negative in to the parentheses, then it would be minus log x minus log y. Yes. Okay, at this point, you may have gotten confused and said, okay, is this simplified? Is this not simplified? At this point, we have simplified it. But what if I changed the base? What if now I had a base of 3 for my logarithm? Why would I do that? I think it's fun. Okay? But wait.
27. I had a kid ask me a good question.
Okay.
Andrew, ask that question. What 27? Ask me something about 27. Granny.
Did you,
Could it be just 3 minus the rest of it? Because you could simplify it out to 3 to the third?
yes.
Yeah.
So, even before we changed this base here, if we just had the original log of 27, technically couldn't we also write the 27 in terms of base 3? Or in terms of 3? So if we have a 3 here, what will our power be? 3 as well. And if you have something that is in your exponent, using the power rule, what could you do with it? You could pull it out using the power rule. So then this would become 3 log of 3.
I get asked a lot, is that more expanded? And I don't know what to tell them other than it's a little wider because it's got a 3 in the front of it. And so, yeah, we usually require you to expand it.
So what Mr. Server is saying is, if you can expand it or find some kind of exponent that you can then factor out, like we did here,
That's the only thing you would
you should.
You lost 5%, but that's still, it stings a little bit.
Okay.
So,
Good to know.
on the test, I'm going to be back by the time you do this test. Know that you have to have that argument. It's like 27. It has to be broken up into exponents.
Okay. So from this point, we are saying that this, oops, now I'm adding bases everywhere. If we wrote out our original equation in this form, this would be considered the most expanded and simplified form. From this point, though, if I add a base of 3, as Franny was saying earlier, if we have a base of 3 here, that means that we have log base 3 of 3. What's log base 3 of 3? 1. So then we have 3 times 1, which is just 3. So if you have a different base, or if you have some base where it goes into whatever your argument is, then you can simplify the problem a little bit more. Okay. So this was a little bit more of using the properties of our logarithms in order to expand and condense different problems here. But I want to go back to what we just talked about with if you had, for example, what we had before, log base 3 of 27. And we already know that we can rewrite that as log base 3 of 3 to the power of 3. And yesterday we talked about how we could use a shortcut and just say this will cancel out, and all you need is just to select the power, and that will give you your answer. What I want to talk about a little bit today is this happens in the case of logarithms. There is a similar case that will happen with exponentials. That similar case shows up when, for example, you have 4 to the power of a logarithm. Specifically, here, if you have a power to the logarithm with a base of 4, then what happens here is there is a shortcut, but I would first like to show you the long cut so you know why the shortcut works. So this long cut here would be if we have this base of 4 and we have this logarithm in our exponent. I personally don't like logarithms in the exponent because that just looks really ugly, doesn't it? It looks really intimidating. So what I would like to do is I would like to take this logarithm in the exponent and I would like to bring it down. What method do we always use if we have something in the exponent and we want to bring it down? Which property do we use? Our bases are the same. Or, don't we have the power rule? Where if the power rule, if we have some kind of logarithm in front of the 4 here, then we could take this and bring it down in front of the logarithm. So now our only problem is we need to have a logarithm. But we also want to be really careful with our logarithm and say, while we're putting a logarithm into this equation, is there a logarithm that will help us get rid of this 4 too? So if I have a logarithm and a 4, what base would I need in order to get rid of that 4? 4. So if you have a base that is equal to the base in your argument, then we still have that exponent there, but you can take that exponent and you can bring it down in our next step. But before we go into our next step, if we put a logarithm with base 4 on our right-hand side, we changed our equation, which means we have to do it to the other side as well. So now we're going to have log base 4 of y on the left-hand side. And as we were aiming for, this base of 4 and this base of 4 in our argument means that we can cancel these out. And all we're left with is just our exponent. So then all we have is log base 4 of y is equal to log base 4 of 7. So y equals 7. Because if you look at this, these are the same. So then these must be the same. So we end up with y equals 7. If we look back at our original equation, where was the 7 in our original equation? It was all the way here at the end after the logarithm. So the shortcut for us would be, if you have in your argument a base, and in your exponent you have a logarithm with the same base, you can cancel these out, and all you have remaining is just 7. So, if I asked you, let's go with what's the base of the natural log? 2.71, which is also known as a letter, e. So what would y equal here? 20. If you have an e in your base, and here your logarithm has a base of e, so they have the same base. So you can cancel them out, and all you're left with is y is equal to 20. Nice little shortcut for us. From this shortcut, let's combine what we were just doing with what we were doing at the beginning of the period. I would like you to condense this as much as you can. Gotta make sure I get this right. That is an 8 to the power of e, which is to the power of the natural log of x. I would like you to condense this, and I will pause the video while you are condensing. Okay, who would like to start us off? Yes, Maddie. Okay, hold on 1 second. We'll do this every time. There you go. Okay, so we're going to simplify with this e to the natural log of x.
Is ln of x equal to log of e, then it simplifies to the x.
So we can cancel this out, and we're just left with the x. So if we rewrite this, that means we have log base 2 of 8 to the x. Awesome. Yes, Franny? So we can rewrite 8 as 2 to the power of 3. And we still have this x, and using our exponent rules, we know that we just multiply across here, multiply across our parentheses. So we're left with 2 to the power of 3x. And since we have the same base here as well, we can cancel those out, and we are just left with y is equal to 3x. Okay, we are on track. There is one other thing that I would like to focus on today, and if we get to the third thing, then hooray for us, but if not, that's okay. What I would like to look at next are inverse functions. So let's start with, if I had this as my function, and I wanted to find the inverse function, what would be a good first step? So we could find the inverse of the slope. That would help us. In general, if you're looking for some kind of inverse function, isn't it always true that all you have to do is you take y and you switch places with x? So finding the reciprocal would get us to the same point in this case. But in general, if we just rewrite this just by switching the x and the y, then we solve this for y, then we will end up with the reciprocal of our slope. And so for something like this, you could just find the reciprocal of the slope. But we're going to start thinking about this in terms of exponentials and logarithms. Before we do that, though, if you think about the operations that you've learned so far, for example, if you had 2x is equal to y and you wanted to get x alone, you have a 2 times an x, so you would use the opposite operation. And what would the opposite operation of multiplication be? Division. So you'd use division to get rid of this. If you had a logarithm of x is equal to y, and you wanted to get rid of a logarithm, what's the opposite of a logarithm? What else have we been learning? It's the exponential. So the exponential will help us get rid of this. So what we are learning today is using this idea of the logarithm and the exponential being opposite operations, we can find the inverse function of something that is an exponential or something that is a logarithm. So let's say, for example, we start with some kind of exponential. I would like to start with 3 to the power of x plus 2 minus 4. And if I wanted to find the inverse function, I would do as I said before. I would take my y and put it where my x is, and take my x and put it where my y is, and end up with x is equal to 3 to the power of y plus 2 minus 4. But now I have to solve for y. If I'm going to solve for y, that means I need to get my y term alone. So if I want to get my y term alone, what will be my next step, Owen? Thank you. We're going to add 4 to both sides. And so now we have 3 to the power of y plus 2. And our problem now is we have a y, and it's in our exponent. If we have something in our exponent, and we want to get our exponent down, what rule are we going to use? What property? The one we put at the front, the power rule. But in order to do that, we need a logarithm first, right? If we want a logarithm first, and this 3 is our base, what would be a good idea to put as our logarithm? So we would have a logarithm with a base of 3 with the rest of our equation on the inside of that logarithm. And since we did it to the right side, we have to do it to the left side as well. So now we have a logarithm. And just as we wanted to do, we can now take our exponent here and move it out front. So we will have log base 3 of x plus 4 is equal to y plus 2 times log base 3 of 3. And what's log base 3 of 3? It's just 1. So technically, we can just cancel it out. I'm going to cross it out, and I'm going to write a 1 underneath, because that's technically what it becomes. So we will have a y plus 2 times 1 on the right-hand side. And on the left-hand side, we have changed nothing. Okay, one more step. We need to find y alone. We're going to subtract 2. We end up with y is equal to log base 3 of x plus 4 minus 2. I would like to give you one to try now on your own. Y is equal to negative 2 to the power of negative x plus 1. Before you start on this one thing to think about. Can you have the log of negative 2? You can't. If you put this into your calculator, it'll say non-real answer. Can you have the log of 0? Ready? It would not. Because remember, an exponent in the base, or sorry, in the exponent, is kind of like the same thing as saying this is negative 2. Excuse me, hold on. Negative 1/2 to the x, like that. So those would be equivalent. But you are not getting rid of both negatives, because there are 2 negatives. That's a good question. Okay. Can we have log of 0, though? If you put that into your calculator, what do you get? An error. Can't have this. So neither of these work, because remember what the domain of our logarithm was? What does x have to be greater than? 0. Our domain is that x has to be greater than 0. So you can't have any kind of negatives or zeros inside your logarithm. So keep that in mind while you are solving for the inverse function here. I will now let you solve, and I will pause while I walk around. Isabel, can you tell us what you did for your first step? Okay, so we have y, oh, just kidding. Before we even do that, from our original equation here, I think we need to switch places first. I forgot to do that, but you are right. Once we have switched places, then we'll have x minus 1 is equal to negative 2 to the power of negative y. And if we're looking at this, if we put this in logarithms right now, something would go horribly awry. So let's multiply it by negative 1 first, because you can't have this negative 2 inside of a logarithm. So if we multiply both sides by negative 1, you'll end up with negative x plus 1 is equal to 2 to the power of negative y. And from here, Ava, what was your next step? Okay, would you like to call in a friend here? Okay, I'll roll the dice for you. Row 6, person 4, come back up, Walt. Okay, let's work on this one together as a class then. We need to take a logarithm of both sides. So we're going to put a logarithm in here first, and then let's decide on the base together. Why 2? Because it works. If on this side we have a 2 to the power of negative y, we want to get rid of that 2 nicely. So if we have a base of 2 in our argument, we would also like a base of 2 in our logarithm. So I am going to agree and say let's use log base 2. So we will have log base 2 of negative x plus 1. And if on the right-hand side I now take my exponent and move it out, I will have negative y times log base 2 of 2. And Walt, do you know what that is? Log base 2 of 2. Same basis for both. So if we have log base 2. Okay, so if we have log base 2 of 2, since we have the base in the logarithm and the base in our argument and they're the same, that means this will equal 1. And this is negative 1. Okay, our final step here is that all of this is equal to negative y, and we want it just equal to y. So you will have y is equal to negative log base 2 of negative x plus 1.
Wait, why is it still negative x to be divided by negative 1?
So originally it was just a positive x minus 1 up here. So our question was, why is it a negative x? And if we have an x minus 1, earlier up here we multiplied both sides by negative 1 and got negative x plus 1. And then that was put inside of our logarithm. And once this is put inside of our logarithm, you can't really change it without taking out the logarithm, which we never did. So whatever is inside of our logarithm has stayed the same all the way to the end. And the only thing that becomes negative is what is outside of our logarithm, which is just right here. Okay. Can someone remind me when this period ends? In 2 minutes? Oh man. Okay. So can I give you one problem to work on tonight? And if you don't finish it, that's okay. But if you do finish it, that would be great for tomorrow. I would like you to see if you can figure out what to do if you're going the opposite direction. So if we start with the logarithm instead, I will give you a hint. You eventually want to get to some kind of point where on the right-hand side here, all you have is just the log of x. And that's all you have on the right-hand side. You should get to that point at some time in your solving. And if you do, you are on the right track. And from there, would you also like me to give you the answer to work towards? Or is that okay? Post it on Schoology? Okay, I will post it on Schoology. That will be it for today. So I'm going to end our recording here.